Today we're going to look at the measurement of shapes, and specifically the measure of the interior angles of a shape. If we look at this triangle right here, we all know that the sum of the interior angles of any triangle is 180 degrees. Secondly, if we look at this quadrilateral, it kind of looks like a square, but it could really be any quadrilateral. We should kind of know that the interior angles are going to be 360. If it was a square, remember we could say this is 90, this is 90, this is 90, this is 90. But for any quadrilateral, you can split any quadrilateral into, by its diagonals, into two triangles, this one having 180 degrees, and this one also having 180 degrees. The definition of a diagonal is that if you pick one vertex, it would be any of the non-adjacent sides that you would, vertices that you would connect it to. We can do the same process down here if we pick any vertex here and we draw just the diagonals from that one vertex. We'd cross over to here, we'd cross over to here. How many triangles are formed? Well, there's 1, 2, 3 triangles. Each of those 3 triangles is going to be 180 degrees. So really to figure out how many degrees are within this entire shape, it's going to be 180 times 3 or 540 degrees. For this hexagon, 6-sided, all we're doing is we're basically drawing the diagonals. So we draw them from just really any vertex. And if you drew them from any vertex, you'd still get the same amount. There would actually be 4 triangles formed here. I know that I didn't draw very straight lines, but each of those would have 180 degrees for each one of those triangles. So this would give us 720 degrees for the interior angles of this shape. So this 3-sided shape basically has 1 triangle. This 4-sided shape has 2 triangles. This 5-sided shape has 3 triangles. And this 6-sided shape has 4 triangles. We try to notice the pattern. We try to use inductive reasoning here, that if we have 3 sides, well, there's just 1, 4, there's 2, 5, there's 3, 6, there's 4. If there were 7 sides, how many diagonals do you think there would be? Or how many triangles on the inside do you think there would be? There would probably be 5. I think that the pattern here is that we basically are taking this number, the number of sides, and we're kind of just subtracting 2, aren't we? Each time we just subtract 2 in order to figure out from the number of sides to the number of triangles that exist inside of them. And then once we have that, since we know that there are 180 degrees in each triangle, we're just going to multiply this number that I have kind of in parentheses here, this n minus 2, we're going to multiply that by 180. So let's take a look at and formalize some of this. Our goal again today is to discover the sum of the angle measures in any polygon. So specifically for quadrilaterals, it says the sum of the measure of the 4 interior angles of a quadrilateral. When those all add together, you can think of a square or any quadrilateral you want to think of, they always add together to be 360 degrees. For a pentagon, remember there's 5 sides for a pentagon, the sum of the 5. When we take it, it's basically 3 times 180 degrees. Well, that will give us 540 degrees. So any pentagon, no matter how you draw that pentagon, the sum of the interior angles is always going to be 540. So then we kind of get to the in general. So any for any n-gon, which has n angles, interior angles, the sum is going to be, well, we're going to take n minus 2, so however many sides it has, and we're going to multiply that by 180 degrees. That's in general how we figure out this. And this is really kind of an important formula. This is really what we're aiming for today. So when we talk about this is going to be a convex hexagon. The hexagon is going to have 6 sides. So we're going to say n equals 6. And remember our formula is n minus 2. And we're going to multiply that by 180 degrees. So this would be 6 minus 2. It's in parentheses. We have to do that stuff first. Times 180 degrees. That's 4 times 180 degrees. That's going to equal 720. So any hexagon, no matter if it's stretched out like this, whether it's a regular, equiangular, equilateral hexagon, or just kind of one that's stretched out like this or drawn in any other way, if it's convex, it'll have the sum of the interior angles will be 720. If we look at this, this is actually a convex decagon. Deca means that the sides are going to equal 10. So remember our formula is n minus 2. We're always subtracting 2 from that number. We're going to multiply that by 180. So 10 minus 2 is 8. We'll just take 8 times 180. I'll grab my calculator here. 8 times 180 is a pretty big number. times 8. This would give us 1,440 degrees. So that's the sum of the interior angles of a regular decagon, any decagon. Yes. So again here, this says n equals 10. We'll kind of see these in a slightly different way. So that means we'll say 8 times 180 degrees. Again, 8 times 180 gives us this 1440 number. So 1440 degrees. When we have n equals 17, we'll say 17 minus 2 gives us 15. So we'll take 15 times 180 degrees. So 15 times 180. That'll give us 2,700. Why don't you guys try by yourselves? Why don't you guys try a 13-gon and an 8-gon? I think this is a very strange name for it. I would call this an octagon personally. Why don't you guys take a minute, pause this recording, come back, and we'll have some answers for these two. Okay, welcome back. Hopefully you identified the n for this is going to be 13. So we're just going to say 11 times 180 to get our answer, because there's going to be 11 triangles that you can draw on the inside. That should give us a total of 1,980 degrees. I think it's pretty important that when we talk about this that we're getting the number of degrees. Sometimes when people don't write degrees up here, they kind of confuse it with either the number of triangles or the number of sides or something else. Remember that again, an octagon, we'll say this is going to be 6 times 180 degrees. So 6 times 180 will give us a number 1,080 degrees. Okay, so these turn out to be our answers. We can keep working this. We can actually work these problems backwards. If the sum of the measures of the interior angles are here, then we want to classify the polygon by its number of sides. Okay, so what we're saying is that 1,260 is going to equal, well, n minus 2 times 180. Well, if we're going to solve for 1,260, the first thing we need to do is we need to divide both sides here by 180. So we divide both sides by 180. 1,260 divided by 180 is going to give us 7. 7 is going to be n minus 2. We then add 2 to both sides. My n now equals 9. What's a 9-sided polygon called? Yep, that's a nonagon. Nonagon. Okay, we'll do the same thing over here. 1340, we'll just say n minus 2. We'll put this in parentheses, times 180. First thing we'll do is we'll divide both sides by 180 degrees. Again, degrees divided by degrees will cancel your degrees. When you take that number divided by 180, we'll get 18. 18 equals n minus 2. So when we add 2 to both sides, n will equal 20. That's not our answer. Our answer is actually to classify it by its number of sides. So we'll name that polygon. Will be a 20-gon. Why don't you guys just take a little bit of time? There should be a 0 at the end of this. This is kind of weird. It's kind of a strange problem in general, but why don't you guys try these next two on your own? Pause and try these two. Okay, welcome back. Again, we'll just set this n minus 2. Hopefully you already got your answers, so I'll go through these quickly. We'll divide both sides by 180. That would give us 12 equaling n minus 2, or that n equals 14. We would call that a 14-gon. Okay. Let's take a look at letter D here. Letter D was kind of a weird one, just because of the number of degrees and everything that we have. We have 11,160 equals n minus 2 times 180 degrees. If we divide both sides by 180, we'll actually get 62 equals n minus 2. Well, this is 64 equals n. So that means that we're going to have a 64-gon would be the name of our polygon. I don't think it would be a bad idea to kind of review and to make sure that you can go all the way from 3, so 3, 4, 5, 6, all the way up to a 12-sided shape. You could name this as a triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, and a dodecagon. Make sure that you're able to name each of those shapes by the number of sides. Okay, now it's a kind of a story problem. It says the sum of the measures of the interior angles of a convex polygon is 1260. Classify the polygon by its number of sides. I feel like we did a problem just like this already, but really all we're doing is we're just going to be using our formula again, like this. We'll divide both sides by 180 degrees, the whole thing. This will give us 1260 divided by 180. Should give us 7. 7 equals n minus 2. We'll add 2 to both sides. This is just showing all of our work. N equals 9. And if n equals 9, this is called a nonagon. Whoops, not a very good job circling that, but it is called a nonagon. Example number 6, it says the sum of the interior angles of a convex polygon are 1620. So we'll say 1620 equals n minus 2 times 180 degrees. I'll close this parenthesis. We'll divide both sides by 180 degrees. We'll do this on both sides here. 1620 divided by 180 should give us 9 on this side. 9 equals n minus 2. We'll add 2 to both sides. It's really not very tough math that we're working on here. N equals 11. And remember that an 11-sided shape is called an un. Oh, I didn't even spell this correctly. An un decagon. Okay, so un meaning 1, deca meaning 10, and gon meaning the shape. So we're basically at 1 plus 10 is 11. An un decagon. Okay, so this is kind of what we're working on. I think it's a really good idea for you to realize kind of what we're looking at here for this very first shape here is that this is what we need to do. You don't necessarily memorize these numbers. These are okay numbers to memorize and everything else. But I think if you were to memorize something, just kind of memorize this formula and realize that it's always for the interior angles of an n-gon. Okay, the sum of the measures of the interior angles of an n-gon. If you guys have any questions, make sure to let me know. I'm more than willing to help you with this. Come see me in the morning if you guys have any questions.